Am I audible? Am I audible, बच्चों? Am I audible? Adnan, am I audible?
Yes, sir.
Yes.
Okay, बच्चों. So, if a body is at rest, its velocity is zero, hence its momentum is zero. But every moving body possesses momentum. The body which is in motion has momentum, and momentum is a vector quantity. We can take the screenshot and we will move to the next slide.
Sir, taken.
Okay, beta. So the SI unit of momentum is kilogram per meter second. Kilogram meter per second. Kg meter per second is the unit of momentum, and CGS, in CGS it will be gram gram centimeter per second. In CGS, gram centimeter per second. The importance of momentum for considering the effect of force on motion. Example, suppose a light vehicle like a car and a heavy vehicle like a truck are parked on the horizontal road. Two vehicles are there. The first is car and the next is a truck. The greater force is applied to push the truck than the car to bring them to the same speed in the same time. So greater force is required to bring both of them into the motion with the same velocity. The car will require a smaller amount of force, whereas the truck will require a larger amount of the force. Similarly, a greater opposing force is required to stop the truck than the car if they are moving with the same speed. If you want to stop two moving objects, the larger force of retardation is required to bring the body which is heavier because of the larger quantity of momentum. So next example, a bullet fired by a gun easily pierces human tissue before it stops. So when a bullet is fired, it can easily penetrate the human body. The same bullet with moderate speed will not cause much damage. Okay. Thus, for a given mass, the greater the speed, the greater is the opposing force needed to stop the body in certain time. Suppose that when you shoot the gun over an object, it will penetrate it by the gun, because then the same mass, it will be around I think 40 grams of per bullet. It will be of 40 grams or 30 grams per bullet, the mass or weight of that mass. So if you project it or if you fire it from the gun, it will have a larger velocity. That is around 1200 meter per second or 1000 meter per second. So because of that great velocity, the bullet will acquire great momentum, larger momentum, and it can easily penetrate even a wooden plank or a human body, because a larger amount of force is required to stop that. But when the same bullet, if you take it in your hand or just throw it with maximum speed what you can, it will not hurt anybody. It will not penetrate the wall or the human body. That is the main difference. Because of the momentum, this is the mechanism of the momentum. Okay. So the same force for the same time causes the same change in momentum in different bodies. So the force not only depends on the change in momentum, but also on how fast change is brought. So the greater the rate of change of momentum, the greater is the force. Hence, we can say Newton's second law. Newton's second law is the rate of change of momentum. F is equal to dP by dt. D by dt means time rate of change. P means momentum. So this rate of change of momentum is called force. I will explain it in the Newton's second law. You can take a screenshot. Okay. So now take another example. Suppose a body is moving along the circular path. In that case, the momentum is a vector quantity again. So if the example do not indicate that momentum is a vector, the following example show that momentum is a vector. So suppose a stone is whirled with uniform speed in the horizontal circle by means of a string, that is called horizontal circle. If you are moving in that manner, if you are moving in that manner, that will be the vertical circle. So there are two kinds of circle when a body moves along the circular path, horizontal circle and the vertical circle. Okay, so this is the horizontal circle. The body is moving around the circular path. On the circular path, the momentum, the magnitude of momentum is constant, but its direction keeps changing continuously. I want to ask a question: why? Why its momentum is changing continuously, but its magnitude is same? I explain it in the class today at this school only, na? Can anyone answer? What is the
Sir,
reason
because
behind
of
that?
direction.
Yes, because of the direction, because the velocity changes its direction at every point, because the direction of the velocity is getting changed. So the direction of the momentum is also getting changed because momentum is proportional to the velocity. So the magnitude of velocity is same along the circular path as the body is moving, but the direction is changing. So the direction of the momentum is also changing. Okay. So a force is needed to change this momentum vector. A force is needed to change this momentum vector, and this force is provided by hand through the string, and it is also felt by the hand. If you take the stone, if you rotate it, so that force is supplied by your hand, which is changing its direction on every point, and the body is describing the uniform motion along the circular path. So you can also take a screenshot again. Please take the screenshot quickly, yaar.
Taken, sir.
Okay.
Sir, taken.
Okay, beta. Good. So now we have completed Newton's first law. So Newton's first law was the law of inertia, because it was based on the experiment or the statements of Galileo. So now comes the second law, Newton's second law of motion. So the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So whenever you apply a force over a body which is at rest or it is also moving, when you apply the force, the body moves in the direction of the applied force. Therefore, because force has a point of application, the force has a point of application, so therefore the force vector is called polar vector. Whenever a vector quantity has a point of application, then we can say it is a polar vector. So in that case, the force is directly proportional to the change of momentum, rate of change of momentum. So force is proportional to the change in momentum. Force is proportional to the change in momentum. Change in momentum, change in time. So we can say time rate of change in momentum. So if force changes the velocity of a mass from v to the v plus del v, means this is the final velocity here. V is the initial velocity, v plus del v means initial velocity plus change. when the change is added, it will be the final velocity. Then its initial momentum is, because mass will be the same, vector P is equal to mv, vector V. But the final momentum will be change in momentum, because momentum will also change with the change in velocity. So that del vector P means, delta vector P means change in momentum is equal to mass into change in velocity, because momentum is proportional to the velocity. So according to the Newton's second law, the force is proportional to the rate of change of momentum, Again, if you remove the symbol of proportionality, you will find a proportionality constant here. So F is equal to, force is equal to K del P by del T. So where K is a constant of proportionality and the force will be K. Now we are limiting del P, the rate of change of momentum with respect to time. We are limiting it, means we are assuming that time is constant. So we are limiting del T approaches to 0. So when the time will become, change in time will become 0, means time will be constant. At that constant time, or at that particular instant of time, the value of force will be dP by dt, means force is equal to rate of change of momentum, or the instantaneous momentum. So force is equal to, we have substituted the value of momentum. The value of momentum is the product of mass and velocity. So here we have kept here mass and the velocity. So F is equal to K d by dt mv. Next step, because mass is a scalar quantity and it is constant, we have taken it as a coefficient. I explained the differentiation while I was teaching a differentiation. I taught you second rule of differentiation, that is constant rule. That is coefficient rule. So we have taken the mass as the coefficient and we are differentiating the velocity. So the force will be km dv by dt, km dv by dt. In the next step, the rate of change of velocity is called acceleration. So the force will be kma. M is constant and a is the acceleration, which is equal to the rate of change of velocity. So we have derived force as the product of mass and the acceleration. The force of 1 Newton applied on a body of mass 1 kilogram produces acceleration of 1 meter per second square on the body. If you apply the force of 1 Newton on a body of 1 kilogram, then the force will accelerate the body by the amount of 1 meter per second square. Okay, so this is called Newton's second law. This is a derivation of Newton's second law. So it will be 1 is equal to K into 1 into 1. So here the value of K is 1. So we have derived the value of K. Whenever a force of 1 Newton acts over a body of 1 kg and accelerated in its own direction by 1 meter per second square, then we get the value of this proportionality constant K as 1. Now you resubstitute the value of K in any of this equation, in the last equation, then you will find F is equal to ma. F is equal to ma, and it is Newton's second law. So we can define Newton's second law by two definitions. The first one is the force is equal to the rate of change of momentum. The force is equal to the rate of change of momentum. This is Newton's second law. Or we can say the force is equal to the product of mass and acceleration. It means whenever a force is applied over a body, the force accelerates the body in its own direction. Or we can say that when the force is applied over a body, the body accelerates in the direction of the applied force. This is called Newton's second law. Is it clear? Is it clear?
Sir.
Okay, Vita. You can take the screenshot.
Yes, sir.
So force is equal to mass into acceleration. Force is equal to mass into acceleration. Now, what is acceleration? We can derive acceleration from this equation. Acceleration is force upon mass. Acceleration is force upon mass. From Newton's second law, we derive acceleration. So the acceleration produced in a body is directly proportional to the force acting on it and inversely proportional to the mass of the body. And the force is a vector quantity. Force can cause acceleration and deceleration. Deceleration it can produce, and it can produce acceleration. Deceleration means negative value of acceleration, which acts in the opposite direction to the motion, which reduces the velocity. So the accelerator of a car accelerates it and brakes decelerate it. So when you push the accelerator of a vehicle, it increases the velocity because A is positive. But when you apply the brake, it causes deceleration, means the velocity decreases. The unit of force is Newton, as you know it. The 1 Newton is defined as the force which, when acting on a body of mass of 1 kg, produces an acceleration of 1 meter per second square. If you are applying a force over a body of 1 kilogram and the body has an acceleration of 1 meter per second square under the effect of that applied force, in that case, this force is called force of 1 Newton. So you can be asked in the exam, define 1 Newton. So you can define by using this. So place an 100 gram on your outstretched arm. The force you feel is nearly 1 Newton. If you take weight of 100 gram in your hand and you stretch it, so you will find if force acting on your head that will of 1 Newton. One Newton of force, 100 grams, you will feel the 1 Newton of force. You can take the screenshot.
Sir, taken.
Okay, beta. So some important points about the second law. Students, listen. Newton's second law is very important because it is called real law. Actually, we can derive first law from Newton's second law, as well as we can derive second law from the second law only. So therefore, Newton's second law is called real law, which is very important. So understand it. Huh? So in the second law, if the force is 0, implies that acceleration is also 0. Whenever the force acting on the body is 0, the acceleration will also be 0. This is obviously consistent with the first law. Means in the absence of external force, the body will be at rest. Yes, so it is in consistency with the Newton's first law. The second law is a vector law. It is equivalent to the 3 equations, one for each component of the vector. So first is along x-axis, force acting along the x-axis, that will be equal to the rate of change of momentum in the direction of x-axis, and we can say mass into acceleration in the direction of x-axis, or similarly in the y-axis and z-axis. If the object is moving in the space, then we can apply these 3, or it is moving in the plane, as the name of previous chapter was motion in the plane, then the x, y, or yz or xy can be applied. So this means that if a force is not parallel to the velocity of the body, if the force is not parallel to the velocity of the body, but makes some angle with it, it changes only the component of velocity along the direction of the force. So the component of velocity normal to the force remains unchanged. And for example, if the motion of a projectile under the vertical gravitational force, the horizontal component of velocity remains unchanged. So in the motion of a projectile under the vertical gravitational force, the horizontal component of velocity remains unchanged, remains constant, and the acceleration is also constant. Okay, I think it is clear.
Yes, sir.
Okay, So I'm changing the slide. You can take the screenshot.
Yes, sir.
Okay. So the equation, third, the rate of change of momentum is equal to mass into acceleration is applicable to a single point particle. Single point particle, however, it is same for a rigid body or even more generally to a system of particles. So I will teach you the system particle after some time. So it will come in your exam. That is next to next chapter. So in this case, m refers to the mass of rigid body or the total mass of the system. If there is a single point particle, then the mass represents the mass of that particle. If we are applying the force on a system of particles, then the mass is the total mass of the particles which are there in the system. So m refers to the mass of rigid body or total mass of the system of the particles, and acceleration refers to the acceleration of the center of mass of the system. So what is center of mass? Suppose that you are simply applying a force over a particle, then the mass is the mass of the particle. And suppose that there are 10,000 particles, and these 10,000 particles forms a system. That means the mass of all those 10,000 particles is concentrating at an imaginary point. Means that point is representing the whole mass of the system. If you apply the force on that imaginary point, the body will come to motion in the direction of the applied force. If the body is already moving with uniform motion and you apply the force in the opposite direction of the motion on that imaginary point, then the system will come to the rest. So the whole system acts like a single particle, and the whole mass of the system is concentrated at a common point, at a single point. That point is called center of mass. That point is called center of mass. Okay. So in this case, m refers to the mass of the rigid body or total mass of system of the particles, and vector A refers to the acceleration of the center of mass of the system. Any internal forces in the system are not to be included in the force, because internal force gives structure or the form to the system. Now the second law is local relation. The second law is a local relation, which means that vector of force at a point in space at a certain instant of time is related to acceleration at that point, at that instant. So the acceleration here and now is determined by the force here and now, not by any history or the motion of the particle. So it is instantaneous in that point. So it was Newton's second law. Now comes the important concept once again, impulse. So first we studied the classical physics example, experiment of Galileo, policy of Aristotle, and then we studied Newton's first law, which is the law of inertia. Now Newton's second law. After Newton's second law, momentum, and after momentum, we are studying impulse. Whenever a large amount of force acts over a body for a very short interval of time, that is called in your hand, suddenly it drops from your hand. What will happen when it will strike with the ground? Obviously, it will break. It will break because the large reaction force, as the glass will drop and it will touch the ground, it will exert its force, its weight on the ground, and the ground, which has larger mass, will react, and the force of reaction will pass through the glass, but for a very, very short interval of time, and its effect will be very large. So the glass will be break. Same thing will happen when a person falls on the concrete from some height. It will get hurt because of the large force of reaction due to the ground will pass through the body in a very, very short interval of time, and the consequence will be damage in the body. But if the person falls on the heap of sand from the same height, he will not get hurt, because as he will fall on the sand, the sand will be pressed, and there will be a time will be increased, because as the sand will be pressed, there will be larger distance, the body will distance larger distance in comparison with the concrete, and it will increase the time. As the time will increase, so the effect of reaction force will decrease, and you will not get hurt. So impulse is whenever a large force acts through the body for a very short interval of time. Okay, so when a ball hits a ball and bounces back, the force on the wall by the wall acts for a very short time, and when the ball when the two are in contact, yet the force is large enough to reverse the momentum on the ball. So in these situations, it is difficult to ascertain to the force and the time duration separately, because it was very, very small interval. You can take the screenshot. So however, the product of force and time, which is the change in momentum, is a measurable quantity, and this product is called impulse. So the product of mass and velocity is called momentum. Okay, but product of force and time is called impulse, and it is equals to the change of momentum. Force is equals to the rate of change of momentum. Okay, but force and time equals to the rate of change of momentum again. So however, the force, the product of force and time, which is the change in momentum, is a measurable quantity. This product is called impulse. Impulse is the product of force and change of time. That is very, very small change in time. You can take the screenshot. Take the screenshot.
Sir, taken.
Okay. So impulse is force into time duration. So change in momentum, force into time duration means change in momentum. And impulse is denoted by vector J. Impulse is denoted by vector J, and it is the product of force and time. So a large force acting for a short time to produce change in momentum is called impulsive force. A large force acting for a short time to produce change in momentum is called impulsive force. And importance of impulsive force in practice: a high jumping or a long jumping athlete is provided either a cushion or a heap of sand on the ground to fall upon. Because of that, to reduce the impulse, the cushion or sand helps to increase the time in which the momentum comes to zero. This decreases the rate of change of momentum and hence the force, because rate of change momentum becomes zero, so the force also becomes zero. So the athlete does not get hurt. So packing materials like thermocol, corrugate sheets, bubble plastic sheets, straw, and the paper strands, etc., are used while packing glassware, chinaware, or electronic devices. Usually these days we are using a thermocol sheet. So these materials help to increase the time in which the momentum comes to zero when jolting and jerking takes place. So this decreases the rate of change of momentum and hence the force. So the articles do not get broken. If you buy a new TV, the TV will be packed in a cardboard box fitted with the thermocol sheet. That is the reason. If the box will drop from the rickshaw, so the thermocol sheets will get pressed and the rate of change momentum will be zero, and the force effect of the reaction force will also be zero. You can take the screenshot, students. There is 9 minutes remaining of this class.
Sir, taken.
Okay. So shock absorbers are provided in vehicles to allow more time during the bumps and jerks. In the car, in cycles, I think now nowadays cycles also have shockers. So absorbers जो है वो होते हैं आजकल भी. And in cars and bikes and in scooters there is a mechanism which are called shockers. So shockers are the absorbers, shock absorbers, which provided in the vehicle to allow more time during the bump. Suppose that the vehicle comes into the ditch, so the weight will press toward the ground, but because of the shocker, the distance will become larger. So it will push and the time will be more and the effect of force will be less. So a seasoned cricket player stops the ball or catches the ball by drawing his hands, allowing the direction of motion of the ball, thus by allowing more time to apply less force. Suppose that if you are catching the ball, you cannot catch it. Suppose ball is coming from there, if you will catch it, so it will strike with your hand, you will get hurt because it will be in it will have larger momentum. So what you will do to decrease the rate of change of momentum, you will lower the hands in the direction of the force. The ball is coming, you are lowering the hand, then you will catch it. So it will decrease, it will increase the time and it will decrease the momentum. Okay, so impulse will be less. So this is the example. So if you catch the ball, you will lower the hand. If you will not lower the hand, you will get hurt. So it will decrease the distance and it will increase the time. It will increase the distance as well as it will increase the time, and the effect of the force will be less. So fast moving cricket ball has a large momentum. In stopping the cricket ball, its momentum has to be reduced to zero when a player moves his hands back. The time taken to stop the ball increases, and hence the rate of change of momentum decreases. That is, the force exerted by the ball on the hands decreases, so the hands of the player do not get hurt. It is very, very important. Please take the screenshot.
Sir, taken.
Okay. Okay. Newton's third law. So today we will complete Newton's law. Okay. Newton's third law. To every action, there is always an equal and opposite reaction. So you know it from the ninth standard. So this statement means that in every interaction, there is a pair of forces acting on the body, interacting objects, acting on the two interacting objects. The size of the forces on the first object equals to the size of the force on the second object, or the magnitude of the force. So this direction of force on the first object is opposite to the direction of the force on the second object. So forces always comes in pair, the pair of action and reaction. So equal to an opposite action and reaction. Okay. So forces always exist in pair, and that pair is of action and reaction. Suppose that if you are walking on the floor, so you are the force exerted by your leg on the ground is the force of action, and ground is also exerting a force on your leg on inclined direction, that is called force of reaction. Because of that only we are able to move on the ground. Suppose that if you are pushing a wooden block which is kept over the ground, you are applying the force by your muscles and the box is moving, but the surface is not smooth, then there will be force of friction which will act in the opposite direction of the force applied by you. So this force of action applied by your hand muscles and the force of reaction that will be between the surface of the wooden box or with the surface of the ground, that will act in the opposite direction. So forces always occurs in the pairs of action and reaction. So note, the action and reaction are just forces. The forces always occur in pairs action and reaction do not act on the same body. Action and reaction do not act on the same body. Action and reaction act on different bodies but simultaneously. There is no cause effect, there is no cause effect relation, as it is misconception. Though action and reaction forces are equal in magnitude, but they do not produce equal acceleration in the two bodies, so or different masses on which they act. Please take the screenshot. I think you have taken.
Yes, sir.
Okay. Application of Newton's third law. So so uh, you are stretching this spring balance. You connected these to spring balance. You are stretching in opposite direction by your hand. So it's a force of action by your right hand. Then the force exerted by the other person or your other hand will be the force of reaction. The magnitude of the forces will be the same, but the direction will be opposite. Or suppose that if you are throwing a ball toward the wall, the force exerted by your hand is the force of action, and the force exerted by the wall is the force of reaction. Suppose that gun, if you shoot a bullet from the gun, it will feel recoiling. So if you shoot the bullet, there will be a velocity in the opposite direction of the bullet. That is called recoiling of the gun. That is recoil of a gun. So force on the bullet is the force of action. Force on gun, that is recoiling, is the reaction. So action and reaction. So if you fill the air in the balloon, and if you leave it by itself, so it will move here and there because the air will come out from the opening in a particular direction, but the balloon will move opposite to that direction. So because of the action and reaction, balloon moves here and there, and a rocket also moves on the same principle. Rocket will also move on the same principle. The hot gases after combustion comes out from the lower end, but the rocket will move in the opposite direction. So when you walk on the ground, your weight exerting the force on the ground, and the ground is also exerting force of reaction on you, and both forces are in balance. But when you inclined, as you move in the forward direction, the previous case was when you are standing at a point, and at that point both forces of weight and reaction are equal and you are at rest. But as you incline your leg, so the force of action is inclined on the ground, and there is an inclined reaction, and it has two components, vertical as well as horizontal component. So this is vertical component and it is horizontal component. In this case, vertical component of reaction is balanced by the weight, whereas net horizontal component of reaction will help you to move in the forward direction. You can take the screenshot of this.
Sir, take